Uh, let's get started.
Okay.
Hello, everyone, and thank you for joining us to celebrate the International Year of Quantum Science and Technology. I'm Dr. Svetlana Barkanova. I'm a physics professor at Memorial University of Newfoundland and Labrador, and also Chair for Inclusion in Science and Engineering, Atlantic Canada, established and funded by NSERC, which is Natural Sciences and Engineering Research Council of Canada. Today, we are so thrilled to have Melissa here, who is going to talk about your quantum future opportunities in Canada. And those are the talks which are specifically designed for high school students. Melissa is a physics-turned-technology consultant helping businesses apply artificial intelligence and quantum technologies. She holds a Master of Science degree from her time studying antimatter at CERN, so that's a home for Large Hadron Collider, and she has been building IE tools and courses since 2018 at companies like IBM in Toronto's Vector Institute. She is currently the IE product owner and financial technology company Zafin. Melissa, we are so thrilled to have you here. Thank you so much for joining, and I'm so looking forward to your talk.
Thank you so much for having me, and thank you for the lovely introduction, Dr. Barkanova. Welcome everybody. I'm really excited to talk to you today about your quantum future and some of the exciting things happening across Canada, and most importantly, how you can get involved. So first, I will share a little bit about, oops, who I am and how I came into physics and then into technology. And then we will do a brief overview of quantum physics, what it is, and then why it matters. And then we'll talk about how Canada is leading the way and how you can get involved. So if that sounds good, we'll go ahead and get started. So like I said, my name is Melissa Valdez, and I am a physicist-turned-technology consultant. Physics was my favorite subject in high school, but it wasn't actually my best subject. I was better in history and languages, but I ended up following my interest. I figured if I was going to spend lots of money to go get a degree, I would do something that I was interested in. And it turned out really well. So I got a Bachelor of Science in Physics from the University of Windsor in 2015. And after that, I had an amazing opportunity to do my master's studies at York University in Toronto. And my supervisor was a part of the Alpha Collaboration, which is a research group at CERN. That is the big particle accelerator ring in Geneva, Switzerland. And that is a picture of me standing outside of the antiproton decelerator. So after these particles smash together, we take some of the antiprotons that are created, E equals mc squared, lots of energy, creates lots of mass. And one of the pieces of matter or mass that we get is protons and antiprotons. So we take that antimatter, slow it down, and study it with lasers and all kinds of other spectroscopy equipment. So really neat opportunity, and that was just as part of following my passion. I got to go study and do my research in Geneva, Switzerland. So a really cool opportunity. While I was studying, I was also really into outreach work. So doing talks like this, doing hands-on activities with students in their classrooms. And I worked with an organization called Let's Talk Science. And they are a national nonprofit organization dedicated to exposing students to science and technology, starting from kindergarten all the way into grade 12. And so as a campus coordinator, I was a volunteer role and then eventually a paid role as a student, which was really nice. And it led to my first full-time employment after graduation. I was able to work at the national office. So this is my little plug that when you're in school and you're volunteering, it's such a huge opportunity for you to network and meet new people, to build skills for your resume and for your interview prep. You'll have stories to tell about a time. Tell me about a time when you solved a problem. And volunteering is a great way to build that. And it also allows you to explore the things you're interested in. So that's my plug. Definitely volunteer. And like I was just saying, networking is huge. And that's actually how I ended up with my second role as a technical consultant at IBM Canada. I reached out to someone in my network, asked them how they liked working at IBM, and it led to my role in their AI practice there, starting in 2018. So that was really exciting work. I was there for a couple of years before I went to the Vector Institute for Artificial Intelligence. That's a research institute in Toronto. Again, I was doing technical education. So taking from my outreach, taking from my tech knowledge, and helping to bring more people into the fold of what is going on with AI. And so we had really technical talks so people could upskill at work. We had more introductory talks. We had ethics talks. There was just so many things relating to this AI boom that we needed to spread the word about, and that was a really exciting place to do it, was the Vector Institute. Some really cutting edge research going on there. And after that, I became a product owner, which is a kind of like a project coordinator, project manager, but for a tech company's products. And so I'm doing that at Zafin right now. It's a financial technology company based out of Toronto. And it's really exciting work where we're using AI to better our products and our tools that our company sells. And we are using them to build faster, to build better, and even to innovate the products the way that our clients are using them. So very exciting stuff. And it all started with my degree in physics. So physics and technology, big part of my background, but both of those are relevant to quantum. And that is how I kind of found this intersection works perfectly at this new field of quantum physics. So I've been following this field for a few years now, and I feel like I can give you a little overview of what is quantum physics. We'll just do a small crash course, and then we can talk a little bit more about why it's so important in 2025. So quantum mechanics is a branch of physics that explains the way that very small particles of matter and light behave. So you can think at the scales of atoms and subatomic particles like electrons. And the reason we call it quantum is because at this scale, the physical properties like energy, they can only exist in discrete values, or what we call quanta. So you can have a quanta of energy or a quanta of light, which is a photon. So these little packages of light and other properties at this scale are quanta. So that's why it's quantum mechanics and quantum physics. Now, there are a lot of really strange phenomena at this scale that we see when you go really, really small that we just don't see at our macro world scales. So one of those phenomena that I think is one of the first that you get introduced to as a physics student, and it's actually still so hard to wrap your head around, is this idea of wave-particle duality. So these little packages of matter and energy, particles and energy, they're acting as both particles and waves at this scale. So what that leads to is properties like diffraction and interference. We don't see those at we don't see interference like this at the macro level unless you're looking at things like sound waves and things like that. But people don't have an interference pattern. So the particles do, though. And so one of the most common experiments that most physics students will do is the double slit experiment. And that's where you start, there's some source of energy on the left side of the experiment, and it starts emitting waves or quanta. And you would expect that when it goes through a wall with two slits, the double slits, that those particles are going through and kind of just hitting the wall on the other side. If you were, shooting a pellet gun or something, that's what you would expect. But what we actually see is once the particles go through the slit, is that we get a diffraction pattern, And that diffraction pattern allows for interference, and the waves can have deconstructive and constructive interference and producing this wave pattern on the wall on the detector. So rather than two holes and just kind of seeing all the particles build up there, we see this distribution of intensity, and it's a wave function. And so particles going through the slits, like particles showing up on the other wall like a wave, both particle and a wave at the same time. That's the conclusion. So really hard for a lot of people to wrap your head around, but that is one of the core tenets of what's happening at the quantum scale, one of the core phenomena that we observe. Another really strange quantum phenomena at this small scale is entanglement. So quantum states of particles can be connected even over really large distances. So an example of this might be electrons. One quantum measure of an electron is its spin. So you can have spin up or spin down. So say you have two electrons that are entangled, and when you change the spin on one, the other has to change too. Now, entanglement is wild because you can separate these entangled electrons from one end of the galaxy to the other, and when you change the spin, they're still going to change in unison to be entangled. That's the whole point. But if the particles are on opposite ends of the galaxy, that's faster than the speed of light or any information could possibly travel. It's instantaneous. And so Einstein said, that doesn't make sense. Light is the fastest anything can go. So this is what he called spooky action at a distance. It's very, again, hard to think about and comprehend. How could this possibly exist, that we have these entangled particles that can communicate over these vast distances? So entanglement is actually a property that we're using for quantum computing and error correction. We'll talk about that in a little bit, but it's a strange phenomena, and we can actually use it to our advantage. And a third quantum phenomena that we observe at this really small scale is superposition. So particles can be in a superposition of states in the quantum realm. So you can think of a quantum light switch would have on and off, just like a classical light switch, but then there would also be the possibility to have a linear combination of the two states on and off. So A and B would equal 1, or kind of add up to 100%. So A could be 0.2 and B could be 0.8, or 20%, 80%. So you have like 20% on, 80% off. That is a new quantum state that can exist, that just in the real world, either the light's on or the light's off. It's not half, unless you're a dimmer. But we're talking about a on-off binary light switch. So these are just three of the many exciting and kind of strange phenomena that we observe at this really small scale. And like I said, we can use this kind of new physics or strange properties of physics to our advantage and build technologies around them. So these are just three. There's many more we could talk about, but I just wanted to give a sense of how different the quantum realm is from our classical realm that you and me interact in. So let's kind of talk about how we're using these properties in the technology that's changing the world today. The three types of quantum technologies that I'll talk about today that are, I think they're the main categories, I would say. The first one is definitely quantum computing. And certain algorithms or classes of algorithms, when run on a quantum computer, will have advantages over running those types of problems on a classical computer. So we call those speed ups. One of the most popular example would be factoring large numbers. We use large number factorization and how hard that is for a classical computer as the premise for a lot of the encryption that we have on the internet, and even for financial transactions and things like that. So RSA encryption is based on how hard it is to factor a large number, find the prime factors for that number. A quantum computer would actually not have that much difficulty. It's easier for a quantum computer because it has access to things like quantum superposition. Factoring these large numbers actually becomes pretty straightforward, and it will break all of the encryption that's based on factorization. So that's a really common example. Not every problem will automatically be better or faster or have an advantage on a quantum computer, but some definitely will, and we know that for a fact. So there's a very large interest in exploring more possibilities for when quantum computers would be advantageous. And then also, when does it make sense to use quantum and classical computers together, or when is it fine to just stay on classical because you're not really going to get much of an advantage on a quantum computer. So computation is one area of intense research and economic activity right now. People are racing to build a 1 million qubit quantum computer, and that would be what they consider the holy grail. So large players are like Google, IBM, Amazon, but also smaller companies and startups are racing, and we have some leadership in that space here in Canada. Another quantum technology that we are seeing transform industry is security. So quantum communication, or using quantum avenues to communicate, is something that we've actually demonstrated already. And the idea is that when a quantum system is observed, it's very sensitive, and it can actually tell when someone has observed it, measured its state. And so that observation leaves a trace, and it would actually allow us to identify, has anyone been eavesdropping on this conversation? And so the premise behind quantum cryptography being to watch, to prevent eavesdropping, to be able to detect eavesdropping and say, nope, this is no longer a secure channel, was demonstrated several years ago. And the irony is that this was such an exciting feat that this most secure video chat ever held was actually observed by dozens of researchers and media and other people as well. But this technology exists today, and it has applications in the military, for national security, things like that. And quantum computation, or quantum communications, are all based on security. So we have some exciting companies working in this space, and of course, governments are very interested in it as well. And the third group of quantum technologies that are really exciting for us to learn about and start to develop further is quantum sensing. So quantum systems, as we mentioned, are highly sensitive. I didn't really mention that for computation, that sensitivity is a challenge. It means that these computers need to be cooled down to really cold temperatures, so that the heat doesn't disturb the system. Has to be blocked from background radiation, things like radio waves, the solar radiation, all kinds of things can actually interact and interfere with the qubits in the computer. But in quantum sensing, we use that sensitivity to our advantage. Very, very small changes in things like a magnetic field or a gravitational field can be detected by quantum systems, and therefore we can now take measurements of those things with extremely high precision. So quantum sensing and metrology are some really exciting fields as well. So I just want to make sure I haven't forgotten anything here. All right. What we're seeing is that many companies, many governments are investing in this and these technologies. And what that looks like kind of globally right now is you see excitement coming from international organizations. So UNESCO, which is the United Nations Education, Scientific and Cultural Organization, they named this year the International Year of Quantum Science and Technology, and we're observing it through activities aimed at public awareness. So talks like this, and that global effort to kind of celebrate the accomplishments so far and get more people engaged in this new technology and these new work streams, the new regulations that will need to come into place. It's just a massive effort globally to bring people into the fold and say, hey, look, this technology is here, it's coming, it's being developed at a rapid pace. We want to be ready for it. We want the talent, we want the knowledge, and we want the funding, the regulation, all of these things. So very exciting to be a part of it as part of this talk. The other ways that we're starting to see investment in quantum, as I mentioned, many big tech companies, as well as small tech startups, are investing in research and development. They're racing to build that quantum computer, and they are trying to get funding, trying to get clients, and it's a big area of growth and economic activity in 2025. We're also seeing a lot of investment from academic researchers and universities. We have, of course, universities and researchers have been working on quantum for about 100 years now, since the first quantum discoveries were made. And so there are areas of specialization all around the world, but you see physics, chemistry, math, computer science departments, they're starting to develop specific courses, programs, scholarships, and research institutes focused on quantum technologies and their applications. So lots of excitement there around talent training and application of that talent. And then lastly, governments, like I said, are investing in quantum for both national security, but also because they recognize that this is a technology that will lead to a boom in economic activity. And if we can commercialize the technology that we're building, that's a great way to create jobs and to expand the economy in our respective countries. So very exciting for governments as well. So the purpose of my talk was to tell you about how Canada is leading the way. So all around the world, we're seeing new investments in these exciting technologies that are emerging and starting to revolutionize various industries. Canada leads the way in a lot of these investment areas, and there's a lot of activity going on. So let me show you some of the ways Canada is at the forefront. So I mentioned we have companies who are trying to build quantum computers and quantum sensors and quantum communication or secure communication protocols. And Canada has companies in all of those areas. Xanadu is working on building a photonic quantum computer that's using light as the way to track data. Like the qubits are little particles of light. They actually have published some really incredible results in scientific journals showing that they have some quantum advantage in certain categories of problem solving. So their computers are functional, they're small, they're noisy, they need error correction, they need to scale to be much bigger so that there's more capability for computation, but they're doing it. They're quantum computing, and they are based out of Toronto and are a bit of a darling in the Canadian quantum space because of the success that they've seen. D-Wave is another exciting Canadian quantum computing company. They were the first ever quantum company in the whole world, and they're Canadian. They're in Burnaby or Vancouver in BC, and they focus on quantum annealing, which is another type of quantum computing, but it is using the potential energy of a system and trying to bring that energy down into a lower energy state. So it's very neat stuff. It is especially helpful for optimization problems. There's a lot of optimization problems around us. Anywhere you're trying to find a minimum value or a maximum value, those are going to be optimization problems. And you want to maximize revenue and minimize costs if you're a business. Tons of those types of problems to be solved. And so D-Wave works with a lot of companies and partners like MasterCard and big airlines trying to apply quantum annealing to solve their problems, their business challenges. So super exciting quantum computation. There's a bunch of other companies. If you go to Quantum Industry Canada, that is a good place to take a look at the variety of Canadian companies leading the way. There's so much going on, and I wish I could spend my whole talk just talking about the Canadian companies leading the way. But we also have a huge amount of government support here in Canada, we are one of the top 10 countries worldwide in planned public funding for quantum computation and technology. So we have more than $600 million set aside, and it's a number that's still growing. We're behind some countries like China and the United States and the European Union, but for our size, that is a lot of money, and we are definitely on that global stage as a leader, showing that we are committed to developing this technology, the talent to build and maintain and commercialize this technology, and those actual commercialization efforts to start companies and to bring that technology to market. So incredible information is available on the government's website. They have our National Quantum Strategy, it's called, and it details how they're putting that money into research, talent, and commercialization. Definitely, if you're interested in that, check out the ISED website. A third way Canada is leading is that we have research excellence. So these are just a few of the research hubs at the universities across the country that have really stood out, but literally every university across Canada has got some incredible research knowledge. Hubs of research excellence like Institute of Quantum Computing, or IQC, at U-Waterloo. There's EPIC, or the Institut Quantique, at Université de Sherbrooke in Quebec. UBC has AMPEL, which I have that acronym written down. They are the Advanced Materials and Process Engineering Laboratory. There's also the University of Calgary is growing. They've got a Quantum City and their Institute for Quantum Science and Technology. And then the University of Toronto has a Quantum Information and Control Lab. So really just anywhere you look, and many provinces across the country, we've got some world-class research excellence in the quantum space. A fourth exciting feature of quantum in Canada is we have geographic hotspots, often centered around universities. So Quantum Valley in Ontario stretches from that University of Waterloo up to the University of Toronto. There's a ton of incubators and accelerators, venture capital, so money, funding that's going into the research and the commercialization of quantum technology in Ontario. Sherbrooke has the district with a Q for quantum. They again have office space and funding and access to internships and co-op students, and it's this big ecosystem supporting the quantum activity, both in terms of research and business development in Quebec. They have quantum computers. IBM Canada housed one of their quantum system ones, I believe, in the Sherbrooke quantum community. So just a huge hotspot for quantum computation and classical computation as well. There's a nice hybrid mix there. Calgary, Alberta, like we mentioned, the University of Calgary is there, but they also have Quantum City. And Burnaby, British Columbia has UBC, but then also D-Wave and Photonic and other major players in the business side as well. So geographic hotspots where talent is concentrating, and it's really world-class work being done in those spaces. I mentioned the incubators and accelerators. One I haven't talked about yet is the CDL, Creative Destruction Lab. They are a accelerator for seed stage startups. These are the early stages of a company when it's just being founded. They will focus on deep tech. So quantum is definitely deep tech that they like to focus on, and it's really become a specialty of theirs. The last I checked, they've launched over 50 quantum startups. And so in 2023, that was like 26% of the 190 or so quantum startups in the world came out of this accelerator in Toronto, the Creative Destruction Lab. So they have this expertise in knowing what it takes to take something very deep tech or new technology, focusing on new physics or newer physics, and commercializing it or turning it into an economic company. So very exciting. work being done there. Very competitive, very, like I said, just world-class talent being attracted there, meeting partners and starting companies. And I mentioned the district in Quebec, and there's a few others that I meant to add, but it looks like I've got them missing from the slide. So just in general, incubators and accelerators are popping up in all of these geographic hotspots to support the academic knowledge being turned into commercial power here in Canada. And then lastly, I'll mention that we also have a lot of conferences driving, international attention and attracting people to come and share the excitement of what's going on in Canada. So there's annual conferences like Quantum Connections, Q Connect. There's a new business invite-only meeting up called Quantum Now. There's a virtual conference that you guys could attend called Quantum Days. It's run by Deep Tech Canada, and that is a conference where you would see student posters, but you would also get talks from industry leaders and people who are working in startups, but also large companies like IBM. So Quantum Days is one that I would highly recommend to anyone here who wants to be a part of the community and start to meet people, because it's virtual. You don't even have to travel. And then we also have a couple of open source communities based here in Canada. There's OQD, which is Open Quantum Design. They are the first open source full stack quantum computer. And so they are inviting the global community to contribute to building out this quantum computer and the software that will run it and allow us to do computation. And it can be highly specialized for things like chemistry applications or like I said, optimization problems. Either way, it's this community of people, and it's open source, and that is a trend that we've been seeing across many technology spaces. AI seems to be straying a little bit from a lot of the open source directives that they had. They figured that if people can see the source code, that they would trust the technology more. We're seeing some companies move away from the open source model. Some are still moving towards it, but it is a really common area where people are contributing to new technology, and Canada has two of those communities right here. Penny Lane is actually the second one that I have listed there. It's related to Xanadu and their photonic quantum computer, and it's a programming language. And again, they have a whole community with courses and how-to articles. Everything is on their Penny Lane website. If you want to check it out, that would be an excellent summer project for any high school students who are interested in learning more. The Penny Lane website is somewhere I would definitely direct you to. So that outsized impact that we have across government and industry and academia is really having Canada stand out on the global stage. And of course, we intend to keep it going. So the last thing that I want to talk about today is how you can get involved. And the short answer is being curious, working on your skills, and getting certified are going to set you up for the quantum future here in Canada with all the excitement going on and all of the growth that we're seeing. So first things first, I would recommend that you make sure you're signed up for your university prerequisite courses, the things that are going to allow you to take programs in university relating to quantum. So you'll want physics, you'll definitely want math, computer science would be helpful, chemistry would be exciting if that's something you're interested in. Those courses are going to give you the foundation in high school that you need to go and study these things at university and either take them out into industry like I'm doing or to continue researching in academia. It's going to open a lot of doors. So you don't want to sleep on registering for your prerequisite courses in high school. Another thing you can do right now is signing up for hackathons, or something that's newer is called a stratathon. Similar to a coding competition of a hackathon, stratathon allows you to form a team and build out strategy for implementing new technologies. So I participated in a stratathon for quantum technology a few years ago, and that was a really fun experience. There's judges, there's prizes, and it's a really fun way to get involved, and of course to meet people too. That is another good thing to put on your resume. And you can attend conferences, like I mentioned, Quantum Days is virtual. If you do travel, if you do have anything going on at your local universities, it's worth it to go in and start making connections, meeting people, and learning from others in the space. It's a little bit harder to do, but like I said, there's virtual ones, and that is a great step for right now. The second thing that you might want to do is start looking into university programs that are interesting to you. So I mentioned we have a ton across Canada. There's a ton of choice. You can go to French language or English language universities. You could look up specific degree programs. You could look at specific subfields. You could find research groups that you're particularly interested in, scholarships that you might apply for, co-op programs where you're taking a semester to actually go and get paid to use the knowledge that you're gathering. Incredibly helpful. A lot of my friends in my physics program did co-ops and found them extremely valuable. Similarly, internships, and of course, when you're in university, you'll be able to attend conferences at your university and with your research group as they travel. You'll want to start building quantum adjacent skills. So if you sign up for a hackathon, you'll practice your programming. If you go to the Penny Lane website and do some coding examples and problems, that would be a really good way to start building those skills. Problem solving, if you're on a robotics team at your school, if you are working part-time, you're going to be building those problem solving skills. That's going to be important. It's kind of the number one skill across the board that every company hiring is looking for your problem solving skills. And you'll need examples of when you solved problems. So getting started on thinking through, what have you done? What problems have you solved in your part-time job and your full-time jobs coming up? It's going to be really key, and whether you're in quantum or not. So problem solving skills for sure. Communication. This is something I think that gets overlooked a lot when it comes to tech jobs. You will benefit if you are doing programming projects, if you've got problem solving experience because you joined a hackathon or because you are part of a team that is competing regionally for an engineering challenge or something like that. If you can communicate what you did, either through a blog post or through a TikTok video or through speaking at a local conference, that is huge. Not only is that going to help you contribute to the community by sharing and bringing others into the fold, but it will help your recognition. Other people will seek you out for your knowledge and expertise. It's going to let people know that you have these skills. So communication is going to be key. And if you are someone who likes to tinker and do small projects, if you can blog about them or post videos about them later, you're going to be in a really good position for the jobs of the future, because people will know this person knows what they're talking about. Here's a history, here's a record of the projects they've done and the exciting things that they're learning. And then ethics is another one I think that gets overlooked, especially right now. We have this example of AI and how it came into existence without anyone being prepared. And education is a very common example of how AI kind of just landed and like set off a little explosion, right? A lot of people were wondering about cheating and about if people aren't really doing their homework, if they have AI helping them, should they be graduating? You know, there's all these philosophical and ethical questions. How do we reprimand people for cheating? What if they didn't actually cheat and we're accusing them of cheating and using AI when they didn't? There's so many things that are related to the introduction of a new technology. We're seeing it with AI right now. I think we're going to see it again with quantum. There's going to be always data privacy and things like that that we need to respect. And the more that you know about ethical technology development, the better. Not only if you are someone who's building it, but if you want to become a lawyer and be someone who is helping to get IP or intellectual property registered to a particular company, or for a scientist that you're working with, there's going to be things like I said, like data privacy. There's going to be things like equitable use of your technology. So ethics is another area where you can build skills and start learning about what does ethical technology look like, and how do you want technology to look in your community. And again, write about the things you're learning, share them with people. That skill set is going to be really important in the future. And then lastly, I would say that you should stay connected. There are newsletters you can sign up for. Quantum Industry Canada has a newsletter. There are multiple conferences that you can look up. You can join social media. There's a lot going on across Canada for the conferences have social media, the newsletters have social media, the companies have social media. So you can see a lot and find a lot there and stay connected that way. And then, like I mentioned, the open source communities, that's a great way to meet people. They often have Discord communities or something similar where you can, like I said, contribute, but also learn from others and find people who are interested in the things you're interested in too. So that is a great way to stay connected in the meantime. So if you stay curious, build those skills, and start to get certified through university programs or through other certificate-based programs, you will be well poised to contribute to all the exciting quantum activity going on in Canada. So that's my talk. Thank you so much for listening. I hope it was helpful. I'm happy to answer any questions that you have. But yeah, hopefully this was an exciting activity for anybody who's interested in quantum, and I hope it got you inspired by all the things to come here in Canada. Thanks so much.